Hello students, today we are going to start the chemical bonding chapter. Okay, this is the chemical bonding and molecular structure. From the Narayana Neat book that I have selected the Narayana Neat book. So this we will study, that is chemical bonding and molecular structure. So let us read out the slides. Okay, firstly we will do the introduction introductory part of this chapter. So first point is there, the attractive force that holds two or more constituent atoms or oppositely charged ions together in different chemical species is called chemical bond, right student? So what they are saying, that is they are defining the chemical bond, student. Chemical bond means what is, it is the force of attraction, student. It's force of attraction which is holding two two or more than two constituent atom. So this is what, student, this line is what doing, student. This is the force of attraction. Okay, force of attraction, what it is doing, student, this force of attraction is holding two atoms, holding what, student, carbon and hydrogen. So this is what is known as, student, this is known as chemical bond. So chemical bonding is what, student, that is force of attraction which holds the atom together, okay, in a molecule, which force of attraction holding carbon and hydrogen in CH4 molecule. Similarly, this constituent particle, whatever these are the atoms are there, these are the atoms. This can be ions also. So suppose it is, we are having, student, that is Na plus and Cl minus. Okay, so these two ions is having the force of attraction. What kind of force of attraction, student? Electrovalent force of attraction. So that is so force of attraction we can write, that is force of attraction, what it is doing in this molecule, force of attraction holding two ions in a molecule, holding two ions in a molecule. So that is what is known as, student, chemical bond. So that you try to understand, student. Chemical bond means that is force of attraction which is holding two or more than two atoms in a molecule, or two or more than two ions in a molecule. So read out again, the attractive forces that holds two or more constituent atoms or oppositely charged ions together in different chemical species, that is molecule, is called chemical bond. I hope the formula definition will be clear. In a chemical bond, both attractive and repulsive forces exist in equilibrium. Means, student, that is when the chemical bond is getting formed, student. So what is the line which we have to understand, student? That is, let us see. Okay, so what is the so whenever the chemical bond is getting formed, student, okay, so in chemical bond what you will find, student, chemical bond, that is two things are there, student. What is existing, that is in chemical bond, whenever the chemical bond is formed, in this one two things are there in the equilibrium. First one is attractive forces, first one is attractive forces, okay, at the same time what is that, repulsive forces also acting, student, repulsive forces. What is meaning of this, student? What is meaning of this? If you try to understand this one, student, meaning, so suppose that is we are having the atoms here, and this is the nucleus, and we know that is nucleus is positive charge, and this is also positive charge, and here are the electrons are there, student, here the electron. So here what is between electron, what will happen, student? Repulsion. This will be what, student? Repulsion. And nucleus, what is also there, student? That is the more both positive charge, that is repulsion. But what it will result, student? No, after combination, what it will result when it is forming the compound, student? So in this case what is happening, student? In this case what is, this nucleus of this and nucleus of this, it will, this nucleus will attract this electron and this nucleus will attract this electron, okay. So there is the attraction force between nucleus okay, in a molecule, and repulsion forces also exerting, student. So that is what is they are saying in student second point. In a chemical bond, both attractive and repulsive forces exist in equilibrium. Next one, student, next point they are saying, that is what is next point. Atoms are less stable and more energetic, hence they form the molecule by losing some energy by participating in chemical bond. So what they are saying, student, that is if you are having the atoms, individual atoms, so individual atoms is having, a student, that is more energy, okay, and but if it is forming the molecule, okay, it is forming the molecule, so more energy implies that less stable, student, less stable, more energy implies that less stable, but molecule is there, student, molecule is there, that is less energy, and if it is less energy, student, so if it is less energy means that is more stable, okay, more stable, more stable. So student, you see hydrogen combining H2, this much of energy is being formed, be released, and here is also energy is being released, okay. Up now, student, you see one diagrammatic potential energies versus intermolecular difference between two atoms, okay, potential energy and intermolecular. So in this axis what is given, student, potential energy, okay, and that is this axis they are intermolecular distance. So when energy is very high, student, so the distance are also high, okay, but when the energy become decrease, you see the energy, if it is the energy is up to here, so see the molecules are close, very close to each other. So when the energy is more, atomic form, so intermolecular distance is more, but when energy is less, students, when energy is less, so intermolecular distance will be also less. So that is what that is mentioned here, student. Next point you read out, student. So what is next point? Next point is there, formation of bond is accompanied by decrease in potential energy. That is okay. Chemical bond formation is always exothermic, means energy released. Exothermic means, student, energy released. Exothermic means what, student, energy released, okay. Next point is, student, what are there here, you see, that is potential when the, this is the bond formation, student, bond, okay, bond form means it is the molecular form H2, here is the, this is the atomic form. So dear student, you see the potential energy of atomic form is very high, but when the potential energy is less, student, so it is chemical bond is formed. So that is same point, the formation of bond is accompanied by decrease in potential energy. Chemical bond formation is always exothermic, means whenever the chemical bond is formed, student, at that time energy is released. Next point is, student, all noble gases are very stable chemically due to the completely filled electronic configuration. Hence all other elements participate in chemical bond in order to acquire the stable configuration. So what they are saying, student, they are saying whatever the noble gases are there, helium, neon and argon we are taking. So helium is 2, so this is 1s2, student. So this is having the stable configuration, this is stable. So if it is stable, student, it will not go in the combination, student, it does not form any bond. So 1s2, 2s2 and 2p6, if you see, student, it is also having the completed octet, student. You can check out 1 2 3 4 5 6. So this is also stable, student, stable. If you are argon, if you are taking, student, what is that is 1s2, 2s2, 2p6 and 3s2 and 3p6. So what you will find, it is also having the octet completed, student, that is complete octet 1 2 3 4 5 and 6. So this is also stable. Since they are stable, student, since they are stable, okay, they are the stable. So what they are saying, do not form bond, do not form bond, okay. Why, student? Because stable configuration. So simply what they are saying, all noble gases are very stable chemically due to completely filled electronic configuration. Hence all other elements participate in chemical bond other than the noble gases to acquire the stable configuration. Now let us move another point, student. Under normal condition, most of the elements do not exist as a independent atoms. They occurs as a molecule because atoms can't exist independently at ordinary condition. So what they are saying, if the if the under normal condition most of the elements, okay, do not exist as independent atom, okay student. So whatever the, if normal conditions are there student, you try to understand. So whatever, if normal conditions are there student, so what is there, atoms do not exist, okay, independently. So here we can write student one statements that we need to write, that is what do we mean by the normal condition. So if you want to understand the normal condition student, so normal condition means that is room temperature. So at normal condition, if you talk about at normal condition, what they are saying student, normal condition, atoms do not exist, atoms do not exist, atom do not exist, right student. This is the first point. Second point, what are there, second point, so that is, at normal condition, at normal condition, that is at normal condition, that is atoms, normal condition, atoms exist in conditions, atoms exist in which form they will exist student, atoms exist in molecular form, okay. So that is what is the, what they are saying student, like that if you are talking about hydrogen and hydrogen, they do not exist in this form, they will always exist in this form, H2 molecule. So that is same point, under normal condition most of the element do not exist as independent atom, they occur as a molecules because atoms can't exist independently at ordinary conditions. Next point, let us read out student. An atom or group of atoms which can exist independently at normal condition is called molecule. Whatever it is existing at normal condition like O2, N2, H2, so they all are what student? They all are, that is the, at atom, what they are saying, an atoms or group of atoms which can exist independently at normal condition is called molecules, okay. So that is at the normal condition what exists student, that is molecule. Next point student, what is their next point, the number of atoms present per molecules depend on the combining capacity of the constituent element. This combining capacity is called valence. So again read out the statement student, quite easy statement. The number of atoms present per molecule depend on the combining capacity of the constituent element. The number of atoms present per molecules depend on the combining capacity of the constituent element. This combining capacity is valence. So I am explaining in the different form student what they are saying. That is hydrogen is there, it is having one electron. Okay, lithium is there, it is having, that is two valence electron, 2s1. Okay, so and if you talk about the magnesium student, this is the 12. So 2, 8 and 2 student. So this whatever they are doing, this is the valence electron, this is the combining electron student, this is valence electron is combining electron, combining electron, which is also known as, that is student, valence electron, okay. And this is implies that valency, the number of electron present in valence cell is known as valency. For example student, valence, the combining capacity of an atom with number of hydrogen atoms or number of chlorine atoms or double the number of oxygen atoms is known as valency. This is very old definition student, okay. Valency is, that is a simple combining capacity, okay, combining capacity. So student, if you see, the nitrogen is combining with 3 hydrogen, so its valency is 3. CO2 is combining with 2 oxygen, so its valency is 4, because the number of valency when oxygen is there, so multiply by 2 is there, double the number of oxygen atom. And is Cl2O7, so if you are saying valency is 7, how is student, that is if your 2x is there and here is 14, minus 14 equal to 0, so 2x is equal to 14, so x is equal to 14 by 2, so that is it is coming plus 7, so valency is 7. Now let us move student, Kessel-Lewis approach for the chemical bond formation. What is the Kessel-Lewis approach, student? This is also called electronic theory of valence or chemical bond theory. Okay, so it is called electronic theory of valence or chemical bond theory or modern theory of valence. Okay, so Kessel-Lewis, what is that is this was proposed on the basis of Bohr atomic theory. According to this, the outermost energy level in an atom is known as valence shell, and the electrons present in it are called valence electron. The electrons present in the inner energy level are known as core electron. Right, student? So that let us try to understand this. So, okay, so suppose I am taking a student, one atom is taking nucleus I am taking. So what they are saying is, student, this is the, so many are there cells is possible. So here is the, whatever the outermost electron are there, student, that is known as valence electron. That is known as valence electron. And what are the electrons are there in the inner cell are there. Okay, so these are known as, student, these are known as core electron. These are known as core electrons. Okay, these are known as core electrons. So what they are saying, student, what they are saying, again you can read out the point, student, better. According to the the outermost energy level in an atom is known as valence shell, and the electron present in is called valence electron. So outermost valence shell electron is known as what? Valence electron. The electron present in inner energy level are the known as core electron. So that I mentioned here. Next one, nucleus plus inner electron is called kernel. No, nucleus plus inner electron. So nucleus plus inner electron is called, student, kernel. Kernel. Nucleus plus inner electron is called kernel. Kernel, student, kernel. Okay. Next point, what they are saying, elements with 8 electrons in their valence shell are more stable than other elements. Okay, so that is second point, that is if 8 electrons are there in valence shell, that is what is known as stable configuration. And atoms must possess 8 electron, in outermost energy level for its stability, octet rule. Hence all the elements try to acquire 8 electron in the outermost orbit, that is octet configuration. Each atoms try to have the 8 electron in their valence shell by combining. Even though helium has only 2 electrons in the valence shell, it is highly stable, chemically inert, because of doublet configuration. Helium is having 2 electron in valence shell, that is it is stable. Atoms attain stable electronic configuration, doublet or octet configuration, either by transfer or sharing of electron. So this is the point which we have to understand, that is how they acquire the stable configuration, by what is their transfer or the by sharing of electron. The number of electron transfer per atom is called electrovalence, and resultant bond is called electrovalent bond. So if the bond is formed by the transfer of electron, if the bond is formed by, student, that is transfer of electron, so that is known as electrovalence. Okay, and the resultant bond is called, that is electrovalent bond. Okay, that is called electrovalent bond. The number of, what they are saying, student, the number of electrons shared per atom is called covalence. Number of electrons shared per atom is called covalence, and the resultant bond is known as covalent bond. Okay, so student, what they are saying, the point which we needs to understand here in this, let us try to understand in the better way. So what they are saying, student, no, transfer of electron is taking place. Transfer of electron, transfer of electron means that is known as electrovalent bond. Electrovalent bond. Okay, electrovalent bond. Okay, and sharing of electron is there. Sharing of electron, so they are saying that is covalent electron, so that is what is forming covalent bond. So that is you keep in mind, student. Next point, if you see, student, what are there, the next point, nature of the bond formed between two atoms, nature of the bond formed between two atoms depends on the electropositive and electronegative character of the bonded atom. So they are saying if electropositive atom and electronegative atom are combining, so that is ionic bond will form. If more electropositive and more electronegative are combining, that is what will bond will form, ionic bond. If the both are electronegative are combining, that is form covalent bond, or that is known as dative bond. If electropositive and electropositive are combining, that is metallic bond will form, student. Lewis introduced simple notation to represent valence electrons in an atoms. They are called, that is Lewis symbol, right, student? Lewis introduced simple notation for represent valence electron in an atom. They are called the Lewis symbol. In these symbols, valence electrons are represented by dots. So lithium is having one valence electron. Okay, lithium you can make it out. 3 electrons. So that is 2 and 1. 1 is valence electron. So lithium is acquiring 1 dot. If you talk about beryllium, so beryllium is having 2 and 2, 2 valence electron. So beryllium is acquiring 2 dot here, you can see, and boron is 3 dot. Lewis structure of elements. So that is hydrogen and lithium, they are having the 1 dot. Magnesium or group 2 element 2 dot, group 3 element 3 dot, group 4 element 4 dot, group 5 element 5 dot, and group 6A element 6 dot. Okay, they can be used to calculate the group valence of the element. Chemical bond, types of chemical bond they are saying, strong bond and weak bond. So strong bond are there ionic, covalent, dative and metallic bond, and weak bond are there, student, hydrogen bond and van der Waals force of attraction. Now we will discuss, that is covalent bond and ionic bond in the next video lecture, student. Thank you so much for watching, friends.